Welcome to the solution for the Kinematics AP problem set, problem number 25. This is our first projectile motion problem. And so we want to do a careful explanation here. Let's start by reading the problem and highlighting information as we always do. The fastest recorded pitch in Major League Baseball. You'll note that I've changed this and updated this question from what it says on your problem set, and I've made it most current. The fastest recorded pitch in Major League Baseball, thrown by Aroldis Chapman in 2010. He plays for the Cincinnati Reds, and he was throwing against the San Diego Padres, was clocked at 105.1 miles per hour. Obviously, that's speed. Let's read the rest to see what kind of speed it is. It says, if a pitch were thrown horizontally with this velocity. All right, so that means that this speed is an initial speed in the x direction. So we'll call it VOX. I think that's supposed to say how far would the ball drop vertically. So how far would the ball drop vertically? And that's XY. By the time it reached home plate, 60.5 feet away. And that 60.5 feet is how far horizontally the ball travels. And so that's the range which we label XX. Let's take this diagram, this picture of Aroldis, and give ourselves a diagram of what's going on in this. His arm is cocked back and the ball is still in his hand here at this spot. So let's suppose he lets go of it about right there. And so this ball has an initial horizontal velocity and is going to start to fall. And let's suppose that home plate is right there. And so what they're saying is the distance from here to home plate, the XX value, is 60.5 feet. And they want to know, if we draw a horizontal line across, how far did the ball drop, which is its XY value, its vertical displacement. Okay? All right, the first thing we're going to address, they give us the range in feet, and they give us the initial velocity, initial horizontal velocity in miles per hour. Both are English system, and so we're going to stick with that. And we're going to do the whole problem in the English system. And I'm going to teach you how to do that and what the G value for the English system is as well. First thing we have to do, though, is we have to convert 105.1 miles per hour to feet per second. So we're going to do a quick little dimensional analysis here. Hours would have to go in the numerator, seconds in the denominator to cancel the hours. 1 hour, 3,600 seconds. Cancel hours. And then we need to go from miles to feet. Miles goes in the denominator, feet in the numerator to cancel miles, and 1 mile is 5,280 feet. That cancels the miles. So we go ahead and we multiply 105.1 times 5,280 and divide it by 3,600, and we get to 4 digits to not figure ourselves out of an answer here, 154.1 feet per second. Really hard to imagine that. Okay, let's go ahead and now tackle the projectile motion part of the problem here. What are we given? Well, this speed is our initial horizontal velocity, and one of the key concepts in projectile motion is that that horizontal velocity remains constant. So the initial horizontal velocity, and this of course is neglecting air resistance, but for the sake of the problem we neglect that. So this initial horizontal velocity is the same throughout the entire trip. What we also know is that horizontal velocity covered a distance of 60.5 feet. So what we can do is we can find out how much time it took to get to home plate. That we're going to use the horizontal equations from projectile motion, and the only one in our pocket to use there is that VOX which is Vx, is xx over t. And you see it's just velocity equals distance by time modified to be projectile motion specific here. So we have 154.1 equals 60.5 over t. And so the time in the air for the ball is 0.392 seconds. Imagine the batter being the batter standing there and the ball being released and in the catcher's mitt in 0.392 seconds. By the way, I'm going to point something out here, that the actual distance, and I'm going to mark it up here on his back foot, that's where the pitching rubber is to home plate, is 60.5 feet. So in reality, he threw this ball at a distance closer than 60.5 feet. So it's getting on the batter even faster than 0.392 seconds. Right? But we don't know this distance between his front foot and the back foot, so we're just using the 60.5 feet generally. All right, so moving on here. We now have the time. We can go ahead and find the xy value, and we're just going to go to our vertical motion equation here, which is xy equals voyt plus 1/2 gt squared. Xy is what we're looking for. The initial velocity vertically for a projectile fired horizontally is 0. So the entire voyt term is 0 plus 1/2. And in the English system, g is 32 feet per second squared. Okay, nice little thing for you to know there. And then we substitute in our time 0.392 seconds. Go ahead and calculate. Pause the video if you need a moment. And we will get 2.46 feet. That's pretty impressive to think about, that this ball drops in 0.392 seconds, nearly 2.5 feet by the time that it gets to home plate. Alrighty, much more on projectile motion in our next class. Lots of practice with this from here on out.